Hello, class. You are welcome to this session on probability. We will start with the definition of probability. So, probability measures the likelihood of an outcome. All right. If I have a fair coin, 20 pesos, 30 pesos, 50 pesos, and I toss it, I will either get a head or a tail of that coin. The likelihood of me getting a head in this case is 50%, and the likelihood of getting a tail is also 50% because the coins we use in our country here are fair coins. So that experiment of tossing a coin is an experiment that gives me two outcomes, and each outcome has the same likelihood of happening. So you can pick a coin now and then try it. Therefore, we are saying that the likelihood or the probability of getting ahead when I throw a fair coin once is 50%. The 50% value there is the 50% value there is the probability. So we say the probability of attaining ahead when I toss a fair coin once is equal to zero point 0.5 or 50%. So you either write it in decimal form or in a percentage form. Okay. We now want to look at some of the basic properties of probability. So we'll start properties of probability. The first property states that the probability of anything or any event always lies between 0 and 1 inclusive. So the probability of anything, I'm using a dot to represent anything, is always greater than or equal to 0 or less than or equal to 1. So we can have the probability of an event being equal to 0. If I have a fair coin, the little coin that has 6 faces on it, and I ask you what's the probability of getting a 7 when you toss a fair coin, it's 0 because it doesn't have a 7 counts. So it's 0, it can never happen that when you toss a fair coin, you get a 0. But if I ask you what's the probability of getting either 1, 2, 3, 4, 5, or 6 when I toss a fair coin, it's 1. Because definitely when I toss a fair die, I will get either 1, 2, 3, 4, 5, or 6. So all those, once I'm asking for the probability of getting either of these 6 outcomes, then the likelihood is 1. Because surely the outcome will be either of these. Right. But if I ask you what's the probability of getting ahead. So when I toss a fair coin, the outcomes are either going to be head or tail. All right, with each having a probability of zero point 0.5 of appearing. So if I ask for the probability of getting ahead when I toss a fair coin once, the probability is equal to what? 1 out of 2 possible outcomes. So the probability is equal to 0.5 or 50% or half. So we realize that 0.5, as you see here, lies between 0 and 1. We can also define this as the probability of anything being greater than or equal to 0, but less than or equal to 100%, which is the same as 1. So your probability may be in percentages or it may be in decimals, but definitely if it's in decimal, it has to fall between 0 and 1. If it's percentage, it has to fall between 0 and 100%. It can be 0 also, it can be 100%. It can be 0, it can be 1, based on the events being described. So this is the first property. Number 2, the probability of an empty set is always 0. So an empty set has no element in there, or either represent empty sets with this or with this. its probability is always equal to 0. Why is this so? So given the experiment of tossing a fair coin, a fair die, sorry, the outcomes are either 1, 2, 3, 4, 5, or 6. Okay. I asked for what's the probability of getting a 7 when you toss a fair die once. The answer is going to be the empty set because we cannot get a 7. So the probability of such a set is 0 because 7 can never happen. Let's look at the third property. The probability of a sample space is always 1. Back to this example of tossing a fair die once. A sample space from a first semester's class is the set consisting of all possible elements or all possible outcomes of an experiment. If I toss a fair die once, these are all the possible outcomes I can get. None is left out. And there's nothing here that is also not passed. So it's exhaustive. I will either get a 1, a 2, a 3, a 4, a 5, or a 6. Okay. So this is the sample space of the experiment of tossing a fair die once. Now, my question is, what is the probability of getting 1 or 2 or 3 or 4 or 5 or 6 when you toss a fair die once? The probability is equal to this the entire set. So the probability is equal to what? Of this, let me label this set as S. The probability of S is equal to 1. Because I'm asking for a probability of getting either of these when I toss a fair die once. And this is the entire sample space of the experiment. So definitely when I toss a fair die once, I'll get my answer will surely be one of these. So once there's certainty or surety of an occurrence of an event, then it is 1. If I ask you now, what's the probability of you watching this video on probability? It's 1 because you are watching it. You're watching it, all right? So that's the third property. Given that S is a sample space, the probability of S is equal to 1. The fourth property states that given two events or two sets, A and B, then the probability of A union B is equal to the probability of A plus the probability of B. All right. So if you have two sets, set A, set B. Set A has elements 1, 2, 3. Set B has elements 4, 5, and 6. The probability of their union, the union of these two sets is A union B equals 1, 2, 3, 4, 5, 6. All right. And the probability of A union B is equal to, in this case, we are considering this as a sum. This is exhaustive of these two. Okay. All right. So in reference to, let's consider this as coming from this sample space. I'm creating a new sample space, 7 and then 8. So let's consider A as a subset of S, and B is also a subset of S. A union B is also a subset of S. The probability of A union B in this case is 6 out of 8. There are 6 elements here, there are 8 of them here. The probability of A, so probability of A is equal to 3 out of 8. And the probability of B is equal to 3 out of 8. All right. So if the probability of this probability, no, probability of A union B. So given that the probability of A union B is equal to 6 over 8, if you sum these two probabilities, probability of A 3 over 8 plus 3 over 8 is also 6 over 8. Therefore, we've proven that probability of A union B, it being 6 over 8, is equal to probability of A plus probability of B, which is 3 over 8 plus 3 over 8. That also gives you 6 out of 8. That's the fourth property. Let's look at other properties. Now, the fifth property states that if A is a subset of B, then the probability of A is either less than or equal to the probability of B. If A is a subset of B, then the probability of A is less than or equal to the probability of B. So once again, let me label these new sets. I'll label this as B and label this as A, okay? Great. Now you see that A is a subset of B. B has all its elements listed out with this set with these elements listed out. A is a set that contains some of the elements of B. So A is a subset of B. Now in this case, the probability of A here is 3 out of 8 possible outcomes. And probability of B is 1. 8 out of 8. If we are considering, all right, so before I continue, let me rather create a new set for B. So this is the entire sample space. I want to have a sample space, all right? That's why I'm changing these. This is the entire sample space. And then a new set of B. B now is 1, 2, 3, 4, 5. Great. So once again, A is still a subset of the set B. And then these two are subsets of the sets of the sample space. Great. So in this case, we realize that if these two sets are subsets of S, all right, then the probability of A is 3 out of 8, okay? And the probability of B is 5 out of 8. We can see from this that 3 out of 8 is less than 5 out of 8, okay? Now we say that a set is a subset of itself. So if you consider the set S alone, whose probability is equal to 1, probability of S is equal to 1, then it's equal to S is a subset of itself. S is a subset of itself. So the probability of S is equal to the probability of S because it's also equal to 1. So that's where the less than or equal to. The less than is seen here, the equal to is seen here. Okay. There's one more property I want to introduce you to. Property 6. Initially, we mentioned that probability of A union B for any two sets A and B is equal to probability of A plus probability of B. And I showed it. Now, there's a case where if A and B have common elements, then the probability of A union B is equal to probability of A plus the probability of B minus the probability of A intersection B. The case where A and B have common elements. Great. Where A and B have common elements. Okay, so this is our focus now. We are done with this. Let's define a set A. We are going back to our sample space. We define a set A as 1, 2, 3. Then we define a set B as 4. Okay, so 3, 4, 5. All right. We see that A and B have a common element 3. 3 is here, 3 is here, and that's it. So A intersection B is equal to 3. What's the probability of A? Is 3 out of 8. Probability of B is 3 out of 8. And then probability of A intersection B is 1 out of 8. There's just one element out of the 3 possible elements. So the probability of A union B is equal to 1, 2, 3. 3 appears here and here. I write it just once, okay? Then 4 and then 5. So probability of A union B is equal to 5 out of 8. Okay. So in effect, we'll say that probability of A union B, given using this definition, probability of A union B is 5 out of 8 is equal to probability of A, which is 3 out of 8, plus probability of B, which is 3 out of 8, minus probability of A intersection B, which is 1 out of 8. So let's see. 3 out of 8, 3 out of 8 plus 3 out of 8 is 6 out of 8. And then 6 out of 8 minus 1 out of 8 is also 5 out of 8. So we've shown that this property is true when A and B have common elements, or they have an intersection. Now finally, the seventh property states that the probability of any set plus the probability of its complement is equal to 1. So let's define the set A. Once again, as it is, we have our sample space and then the set A. What will be A complement? A complement is equal to every element within the sample space that is not in A. So 1, 2, 3 are already in A. So every other thing that is in S that is not in A, we list them out. We have 4, 5, 6, 7, and then 8. So A complement is this element. Now, what is probability of A? Probability of A is equal to 3 elements out of 8. Then probability of A complement is 5 elements out of 8. If you sum 3 out of 8 plus 5 out of 8, you are getting 1. So this is also true. So this brings us to the end of the laws of probability. We'll end with one final law, which is, it's a law on its own. It's called the De Morgan's law. The De Morgan's law. And this law states that if you have two sets A and B, okay, then the probability of A union B is equal to the probability of A. Great. Okay, the probability of A union B all complement is equal to the probability of A complement intersection the probability of B complement. And then the other one says the probability of A intersection B all complement is equal to the probability of A complement union the probability of B complement. So in this case, if you see it where we see that where there's union, the other side is intersection, and where there's intersection, the other side is union. Importantly, note that it is the probability of A union B all complement, the complement of the entire union, okay? But this is the complement of just this set, and then the complement of the probability of just this set. So this is the end of our session on probability, its definition, and the properties. Our next session will look at two important aspects of probability, which is conditional probability and then independence. So see you in the next session.